name is Malik Samar Said, and today I presenting my research on securing electric transportation networks, a machine learning approach. This study focuses on how we can use machine learning to protect electric vehicles, EVs, and their charging station from cyber attacks. With the rise of smart mobility, securing our EV infrastructure is more important than ever. Now this is the agenda. I have structured the presentation into 10 key sections, and we will begin with a brief introduction to the problem and its importance, then go into the machine learning is applied in this context. Okay. We will explore related research, the challenge faces, and the proposed solution, and then we look after we look the results, followed by discussion on strengths and limitation. Then in last I present the conclusion and our recommendation, ending with reference. Okay. Now start with the introduction. Electric vehicles and their charging system are become more connected with which makes them vulnerable to cyber threats like malware and data breaches. Like in introduction, the problem EV and charging network faces cyber threats like malware, data breaches, and our goal is the goal of this research is to use machine learning to detect and stop these threats in real time. Machine learning is ideal for this because it can learn from data patterns and adapt to new kinds of attacks. There are some key terms like cybersecurity, anomaly detection, and resilience. In cybersecurity, like which is protecting system from digital attacks, and anomaly detection, which is spotting anything unusual, and the third, resilience, which means the system can recover quickly from threats. uh, the next slides is application of ML and EV security. There are three major ways machine learning help EV security. And first, it helps with threat detection. This include identifying viruses, phishing attempts, and ransomware attacks. Second one is ML monitor behavior patterns. In this, such as charging habits, if something strange is detected, the system can take action. And the third one is ML allow predictive maintenance. It can identify sign of failure or vulnerabilities before they become a problem. This keep the EV system more reliable and secure. In literature review, several studies show that ML is very effective for cybersecurity. Like for example, in 2020, the chain framework improved how battery system respond to threats by using ML. And another study by Berger et al. In 2022 found that ML detected 95% of false data attacks on the smart grid. This big lesson from these studies is machine work well, but they still need to be trained carefully, especially against smart or tricky attackers, also known as adversarial attack or training. There are some key challenges. Sorry, there are some key challenges. Uh, like even through ML help, there are still some big challenges. Like there are new type of attacks called zero-day attacks can escape detection because they don't match any known pattern. Another key challenge is data variability. Data variability is a problem because EV behave differently based on your habits. For example, one vehicle might show high speed but low usage, which can confuse the system. And then another key challenge is model performance. In this, some machine learning models don't work as well. For example, MLGD2 did not give the best results. Its F1 score was just 0.88, which is low, than what need for high accuracy. And this slide we talk about the proposed machine learning solution of this research. And first, we collect data from electric vehicles, thinking like system logs, charging records, and past threat events like. Second, we apply different type of machine learning models. Supervised model like random forest and super vector machine, which learn from label data. An unsupervised model called k-mean, like clustering, which group data without needing labels. And the third one is we validate the model using a method called five-fold cross validation. This check how well the model perform or different slices of the data. There is an image of machine learning solution workflow diagram at how the workflow look like. First there are data collection, ev log, charging data, thread record, then it will go to processing, pre-processing, cleaning, then model selection, random forest, k-mean, uh, like different type of model like svm, k-mean, then with validation, cross validation, and thread detection. Like this diagram show this term. And in results and analysis of our research, the results were very promising. The best performing model was ML003 with precision of 0.96, recall of 0.94, and F1 score of 0.95. That means it caught threats accurately and with very few mistakes. In one case, it detected malware in EV001 in under 18 minutes. It also flagged strange behavior in EV005, which was using 20% more energy than expected. This could mean either a malfunction or a cyber attack. Another model, ML002, did okay but was not as strong than ML003. Its F1 score was only 0.88, that is less than ML003. And this is a performing comparison of machine learning model. Like in ML003 is like 0.9 something, and the ML02 is like 0.88, that's less than ML003. In this slide, uh, there are strengths like model like ML003 and ML005 were very accurate and reliable than ML002. ML machine learning adapt quickly to a new attack types, making it flexible for long-term use. And if we talk about the limitations, uh, the machine learning 002 ML like ML002 give too many false positive, flagging safe behavior as a threat. The system depends on a label training data, which can be hard to get in real world scenario. मतलब is depending on the label historical data. And last, in conclusion, machine learning is a powerful tool for squaring AV networks, but to be truly effective, these models need to be updated regularly with new data. This research show that the machine learning can adapt to new threats and improve EV safety in real time. And also we need cooperation between tech companies like automakers company and government agencies to make sure these systems are safe and standardized. uh, in recommendation, there are some recommendation that like add real time data, create a standardized protocol, future work in real time data to the machine learning system. This will improve how quickly and accurately threats are detected. and the standardized protocol for AV cybersecurity. This will help all systems speak the same security languages. And the last recommendation uh, is use federated learning in the future. This method allow machine learning model to train without accessing private user data, which protect privacy. And there are some reference that I collect data uh, from my presentation and from my research. And the last word, is there any question? Thank you so much for your attention. I hope this presentation help you understand how machine learning can be used to secure EV system. Thank you.